This video we're going to examine how to factor polynomials. Specifically, we're going to look at the easiest case, which is factoring out a greatest common factor, and we're only going to do it with constants, which means it's plain old numbers. We'll get progressively more challenging problems in later videos. So let's start by looking at how we find a greatest common factor. So just a reminder, if I give you two plain old numbers, 18 and 48, your brain should be thinking, what is the biggest number that goes into 18 and 48? And if you struggle, because a lot of times kids will tell me that it's 2, one way of doing this is to make a factor tree for both 18 and 48. So 18 would be 2 times 9, and anything that's prime you're going to circle. Anything that's composite you're going to continue to factor. So 9 is 3 times 3. So 18 is equal to the product of 2 times 3 times 3. Okay, for 48, I'm going to do 6 times 8. And 6 is equal to 2 times 3, and they're both prime. And 8 is equal to 4 times 2. 2 is prime, but 4 continues into 2 times 2. So 18, or 48 rather, is equal to the product of 4 2's and 1 3. And now, if you look at what's in common, they both share a 2, and they share a 3. So the greatest common factor isn't 2, it's actually equal to 2 times 3. It's the product of what they share. So it's 6. Now, hopefully your math skills are a little better, that you can look at 18 and 48 and with a calculator's help maybe go, okay, so if 2 doesn't go into it, look at 3. Does 3? And 3 does. So then you try 6. Okay, so now that we can identify GCF, let's look at how we factor. So what we have here is a binomial, 12c plus 28. And you want to think, what's the biggest thing that goes into both 12 and 28? Well, 2 does. So then try 4. And they're both divisible by 4. So what you do is you write your GCF first, and then you open up a set of parentheses. In a sense, we're doing the distributive property in reverse. So I'm going to divide each of these by the GCF. 12 divided by 4 is 3c plus 7. 28 divided by 4 is 7. Now, think about this. If you would redistribute, you would get 12c plus 28. So you know that you are correct. But please recognize that this is not the factored form. This is what we started with. This is simplified. Our factors, again, are two things multiplied, or more than two things multiplied together. This is the factored form. And again, that's read as 4 times the quantity of 3c plus 7. Let's try another. This one is a trinomial. So you're going to look at your coefficients and try to decide what goes into both 32, 112, and 64. And one of the things you might want to do is try to divide each of them by the smallest number, like 32. So if you try 112 divided by 32 in the calculator, you get 3.5. So then maybe try 16. And 16, I know, goes into 64, and on the calculator, it goes in 7 times into 112. So I'm going to put the GCF out front, which is 16. And I'm going to divide each of these terms by that GCF. So 32g squared divided by 16 is 2g squared, minus 112 divided by 16 is 7g, and negative 64 divided by 16 is negative 4. So now one of the things you want to do is look at this remaining trinomial and make sure that the greatest common factor of all three terms is now equal to 1. If it is, then you know you can't factor any further with the greatest common factor. So my answer is 16 times the quantity of 2g squared minus 7g minus 4. Again, if we redistribute, we get what we started with. All right, this next one, identify your greatest common factor. So 12, 20, and 24 are all divisible by 2. They're also divisible by 4. All right, so I'm going to start with 4 out front, and I'm going to divide each term by 4. That gives me 3d to the second power minus 5d minus 6. All right, try 4 on your own. Pause the video and check and see if you're right. You should have 2 times the quantity of 3w plus 5 as your answer. 5 has something that's a little bit different than the others. Notice that the leading coefficient here is negative 14w. I never like when my leading coefficient is a negative value. So what I'm in the habit of doing is always factoring out a negative greatest common factor. And 14 does go both into 14 and 98, so I'm going to divide each of these by negative 14 this time, which produces positive 1w plus 7. Right? Now, if you wrote 14 times negative w minus 7, that is equivalent, but the preferred answer is this one on the top that causes the leading coefficient now to switch to a positive value. I'm going to show you in number 6 a mistake that some kids might make. So let's say you look at 24 and 56 and you're trying to find the biggest thing that goes into it. And maybe you think that the greatest common factor is 4. Okay, 4 is a common factor. So you start by dividing by 4, which would give me 6u minus 56 divided by 4 is 14. And some kids would stop there. However, notice that both the 6 and the 14 are still even. So at least 2 still goes into both of these. So we didn't pull out the greatest common factor, we only pulled out a common factor. So if you notice, 2 still goes into both of those. You can continue from this point rather than erasing and starting over. So if I divide everything by 2, there was still the 4 that was out front. So I'd have 2 times 4 out front, and I'm dividing each by this 2 that I'm pulling out to the front, which would result in 3u minus 7. To give me a final answer of 2 times 4 would be 8 times the quantity of 3u minus 7. Now, it is quicker if you had noticed back in the beginning that 8 was the GCF and just divided each originally by 8, which would have produced 3u minus 7 in one step. But you can still get the same answer in 2 steps rather than the 1.